Welcome back, good loved ones. It's your boy Seth Garu Baxter with Maker's Bar, where we're creating 1 million leaders today for tomorrow. Now, if I had the opportunity to be able to explain to you that our technology is moving faster with a rapid rate, this would be the interview that we're going to be really discussing that. Today, we have with us on our show Dr. and I don't want to butcher her name, Dr. Ewelina Kurtys. Correct, doctor?
Yes, perfect.
That sounds good. Now, if we were going to talk about how fast our society is moving, we're going to discuss today with Dr. Kurtys that the human neurons, and doctor, you'll correct me where I'm in fallacy, are generative to create power sources for technology. And Dr. Kurtys is going to be here to explain that to us today. Dr. I want to say it correctly. Dr. Kurtys, please feel welcome and thank you so much for joining us today.
Thank you too.
Absolutely. So, Dr. Kurtys, please explain to us your origin. Where are you from? And give us some of the technology, because I know we're talking overseas right now. You're in Cambridge, London?
Yes, I'm in Cambridge, in the UK. I come from Poland. I'm a neuroscientist by background. I have done a research in neuroscience, in brain imaging specifically, for some years. And after I left academia, I started to work on artificial intelligence because I become really fascinated with this. And I realized that so many things you can do with this, with AI. And it's also inspired by neuroscience. So it's also interesting for me for that reason. And later I started to work on the project, which is the future, what we believe, of artificial intelligence, which is done by Final Spark, a Swiss startup. We are trying to build computers from living neurons. And the reason why we do this
Doctor, real quick, living neurons.
Yes.
That's what I want us to be able to get into. So when you say living neurons, that is from the human being, correct?
Yes, of course. So they are real neurons, the same as you have in your head and I have in my head. We all have neurons. That's why we can process information, we can think. And we know that neurons are very efficient in processing information. They are 1 million times more energy efficient than digital computers. So this is the reason why we try to build AI using living neurons, because we want to solve the problem, which we can see today, that artificial intelligence is using exponentially increasing amount of energy. So today we can still manage, but we can expect that one day it can become a problem. So there are two possible solutions. So one is alternative energy sources, another is alternative computing. And we work on this second part. So we want to make alternative way of computing with living neurons so that we can use less energy for AI.
So, Doctor, I really would like this even possibly be a two-part series. I'd like our audience to really understand. So what we're talking about is taking the human flesh. I don't know, for a lack of simplicity, that's the best way to put it. But human flesh, you can take a sample from a human flesh, and from that helps to be generative to power a computer. Is that what we're talking about?
No, actually, it doesn't power the computer. It becomes a computer. So this is different thing, because we use living neurons, not because we want to connect them, to power our digital stuff, but because we want to build a processor. So the processor itself will be built from living neurons so that they can process information. So instead of CPU or GPU, which you can have in your digital computer, you can have living neurons because they will process information much more efficiently.
So let's break this down. So, doctor, so you can take a sample of my skin off of my
Yes.
arm and then go from there. I think our audience of 388,000, 400,000 now, we're going to. Please break down how you're able to use human DNA to go forward, if you wouldn't mind explaining.
Yes, absolutely. So there are methods since around 15 years in biomedical research that you can get human skin cells and you can reprogram them in order to get stem cells. And from these stem cells, you can produce any type of cells in the body you want, including neurons. So this is just reprogramming the cells. How it works, because every cell in your body has the same DNA, has the same information, but why one cell is a skin cell, another is a liver cell, another is heart cell, is because different genes are activated. So what you do is just you make from the skin cells, you can reprogram them, so they become stem cells. So that means that every gene can be activated in these stem cells, so they can become anything. So you can just switch on the genes which are characteristic for neurons, and this way you get real human neurons, and they are the same as in our head. And this is actually the reason why such a project is possible, because we can produce huge amount of living neurons, human neurons, without any sacrifice. It's very easy to scale. And actually, this process is already commercialized. So you can buy stem cells, which are already prepared from the skin cells. So this is kind of like established process because it's already commercial. And also this kind of stuff is used by labs all over the world. It's just that normally they do this for different purpose, because normally they use it, for example, when you do some experiments on neurons in the lab, you usually want to develop new drugs, or you want to understand how brain works so that you can cure disease. But we use the same method, but for different objective. So objective is to build computer. So to use these neurons to process information the same way as silicon chips are doing today.
Now, let's backtrack just a little bit, Doctor. So that means you take a sample from my arm, and you have a little piece of my DNA from my arm. That can do what? Break that down for us.
No, it's not only DNA, because you take living cells. So you have cell is a bit more than just DNA. So it's a whole structure. So it's like a bag with many things inside, including DNA. And these skin cells, you can reprogram them. So you get stem cells from them. Does it make sense?
Yes, no, it does. Yes, please continue.
Yes. So when you get these stem cells, you can activate the genes which are characteristic for neurons. So you get neurons from that. So they will divide until they get mature neurons, the same as in your brain.
Now, tell me something. What is the difference between how we currently are powering our laptops and computers and phones? What is the difference from how they're powered to using human neurons?
Oh, that's totally different, because today we use computers which are built from silicon chips. So they are totally artificial. They also work in totally different way than neurons. And we know that they use a lot of electrical energy to process information. When you have your computer, or, especially it's clear when you consider large language models. So to build them and also to execute, to use them, you need a really huge amount of energy. But when you have living neurons, they use much less energy. They also work totally different way. So basically, the way how we do this today in our prototype is that we put living neurons on electrodes so that we can send them electrical signals, and we can measure the response from neurons. And the whole process of processing information, what we want to achieve, will happen inside the living neurons, which are using million times less energy than digital hardware. So that's totally different mechanism.
How do you harvest the human neurons?
So actually, we don't really harvest them, from people. We get this process of taking skin cells from humans is already done by someone else. So you can buy commercially. There are companies which are selling stem cells, and we usually start from there. We buy the stem cells, and then we reprogram them in such a way so that we get living neurons.
So, Final Spark is your company, correct?
Well, I didn't found Final Spark, but I'm one of the team member.
So, but I guess I might have better put it another way. So, Final Spark will go to a DNA company. They buy stem cells, and they take us from once you purchase the stem cells. Take us from that step, if you don't mind, and how that helps to create energy for computers and technology.
So we don't really go to the DNA company, but we go to, because it's not only about DNA. So it's generally there are usually companies which are providing different type of materials and chemicals for the lab, and also sometimes living cells. So yeah, we buy these stem cells, and we produce living neurons from them. So this is a process which is called differentiation, and that means that you activate the genes which are characteristic for living neurons. And again, that doesn't produce energy for AI. That's not what we want to do. We want to use living neurons to process information. So we
And
want
how
to
does
use
that
them.
work? Yes. You were forgive me. You were explaining already. Forgive me.
Yes. So we want to use them as alternative for the silicon chips.
Now, how does it work? So, our cells act as a battery. Please explain that process.
No, we don't work as a battery. So the whole point is we don't give energy to existing computer. That's not what we want to do. We want that neurons will process information instead of a computer, which we have today, digital computer.
And now, so now that we are seeing the emergence of AI, where is this impacting that? How is that effectual?
So we would like to run the same algorithm as we today can run on digital computer. We would like to run the same on the biocomputer. So biocomputer will be a computer which will have living neurons at its heart. So as a processor, it will have living neurons. And the difference which we want to achieve is that it will use less energy. So basically, we would like that there is no difference for the end user, but that the difference is that in the price of running the algorithm.
What do you mean as far as in the price? It's less expensive using human neurons?
Yes, in the future, of course, because today we are still on the R&D phase, so we are still working on the prototype, so we cannot really compare. But yes, the future biocomputer will be cheaper because it will use 1 million times less energy than a digital computer. And today, the main cost of AI is energy.
The main cost of AI is energy. Now, so tell me, so Final Spark is the organization. Tell me about your origin of Final Spark.
So Final Spark was founded in 2014 by Fred Jordan and Martin Kutter. So these are two Swiss entrepreneurs. They have PhD in signal processing, so they are more on the mathematics side, on the engineering side. And they have already another company which is very successful, very profitable. And they decided to set up another company, Final Spark, with the dream to build a thinking machine. And this is a dream which many engineers have, and many are discussing the general AI and what are the capacities of the AI, and everyone wants to build a better, smarter AI. So they wanted the same. And they have done for a few years fundamental research on artificial intelligence, on the digital, but they realized that it cost a lot because it cost a lot of energy. And indeed, we can see today that this great success of models like ChatGPT is in a big part because of the huge spending on energy. Of course, it's not only this, but you need, a part of many things, you need a lot of money for energy to make such a project possible. So this is why Final Spark founders realized that this is not possible for a small startup with limited resources. They cannot build thinking machine using digital because it's just too much. It's too expensive, and this is what already big players are doing, trying to do. So it doesn't make sense to compete with them because as a startup you have to come up with something original, something more innovative. And one of our employees, actually the first employee of Final Spark, Jean-Marc, he had already some experience with living neurons because he had a chance to do a project with Professor Markram, which is actually a very famous neuroscientist. And because of that, they thought, okay, maybe it's a good starting point to work with living neurons. So they set up a lab. They learned biology from the scratch. And
Please,
no worries.
please, that is, please forgive me 1 second.
No worries, no worries.
Come here, buddy. He's in the studio today. Doctor, please.
Oh, that's no worries.
Come here, buddy. So, living neurons.
He wanted to take part in the discussion also.
Yes, he did.
He wants to have his voice. Yes. So basically, coming back, yes, they set up the lab and they started to work on trying to program living neurons so that they can process information.
Now, how is this impactful to our emerging AI technology? Because I know a number of people are quite concerned with how AI technology and then also synthetic AI information, how is this impactful or influential to those markets?
Can you repeat actually, because I didn't understand?
For sure. So the AI emerging market and synthetic AI technology, how does how does this impact those technologies?
Which technologies?
AI.
What do you mean? So how synthetic AI is impacting digital AI?
Correct. So the human aspect, or taking human neurons, and my understanding, and this is where I want my audience to be able to grow as well. So previously, we were not using human neurons. Explain the difference. That might be the better way to put it, how this impacts the AI technology.
So the way how it will impact, because for the moment it doesn't, because we are just working on trying to develop this technology. But in the future, if when it will work, it will impact in the way that it will use less energy as compared to digital hardware.
And so, so in getting the human neurons, how would those be harvested? Where would you seek those from? Where would organizations or companies be able to get those from?
Oh, that's actually not a problem. So getting living neurons is relatively easy because you can get huge amount of neurons from stem cells, and this is a process which is already working. So that's actually not a problem.
And so, and how is this a more advanced way of us being able to process our technology? How, where is explain to us the benefit of using human neurons as opposed to synthetic neurons?
So I have to repeat myself. It's all about energy saving.
Forgive me. I don't want you to repeat yourself, but please forgive me. I guess I just was more so trying to break it down. So please forgive me in that way.
That's okay. That's okay.
And now, so in the technology now, and using human neurons, since it's less energy, so that means less impact on our society as far as what we're paying for energy, because we're harvesting human neurons. Is that what I'm understanding?
Yes, but it's not because we're harvesting, because neurons are much more energy efficient. So that's why computers, which will be built from living neurons, they will use less energy.
And now, so 10 years from now, in using this technology, where do you see it going?
Well, so actually 10 years is our timeline. So this is a good choice. So we expect that in around 10 years, we will be able to build bioservers. So bioservers will be central biocomputers. So the processor will be from living neurons, and you will be able to access this like today you can access cloud computing, so remotely. So this is what we envision, because neurons are very fragile. So we think it's better to keep them centrally and then let people connect, so that you will be able to use this cheap computational power, for example, to run different AI models. For example, like today we use large language models. They're also on the cloud somewhere, and we can connect to them remotely. So we have the same idea in mind. And this is maybe can become really important because the energy consumption of AI is increasing all the time exponentially. So one day digital AI might become too expensive for every user. So this is why it's so important to lower the cost of running artificial intelligence so that it will be more accessible to everyone.
So, in using artificial intelligence, are they going to be going the way of human neurons as far as the cost effectiveness?
Can you repeat what do you mean?
Because of the energy efficiency, is it that companies will be going more toward human neurons?
Oh yes, we expect that because the cost is very important factor. If something work with the same quality but is cost cheaper, then of course it's an argument to change for that.
No, tell us, Doctor, how did you get into this? Tell us about your origin. Where do you come from? What got you interested in this field?
So I come from Poland and I studied always biomedical science. After I did PhD in neuroscience, because I was always fascinated by research. I always wanted to be a scientist and was fascinated with the human brain. I still am. I think it's really interesting topic which can be studied from many different perspectives. And later, after I left academia, I started to explore. I started to work with startups and I discovered artificial intelligence. So I realized that you can do a lot of crazy stuff with AI. So it got really fascinated me. And later I started to work on the future of AI, which is biocomputing, which is kind of combination of neuroscience. This what I've done as a researcher and engineering, what I learned during my industry experience.
Now, recently, considering your expertise and where you came from, Peter Thiel was talking about the rapidity of AI technology. Where are you seeing it go? How much do you see it impacting the future of society within the next 5 years?
I think that the next 5 years are very unpredictable, so it's really hard to say. For sure, a lot of things will change because, well, one of the things which we will feel for sure is the automation of many jobs. And many people are afraid of this, but I think it's going to happen. That maybe many jobs will disappear or there will be less need for people. But I also hope that there will be new jobs. So I'm not so pessimistic. So I think that there are two possibilities. Either there will be new jobs, like like we had during the internet revolution. A lot of stuff disappeared, but there are new jobs like, I don't know, search engine optimization manager. This is a job which didn't exist 50 years ago. So I believe in that direction. But another option is that you will have, universal salary for everyone. So that maybe 5% of people will be working and the rest will be actually useless, but they will have to get some money to survive. So I think these are two options which we should expect in the future, maybe not in 5 years, but definitely we will go closer and closer into that direction. So either new jobs will appear or less and less people will be working and we will need to find some solution how to maintain them.
How do you think we're going to maintain them with the new emerging market as such? What should we do? Because the new market will be technology. So those who are less advanced in technological understanding, where do you see the market going?
Well, there is a possibility that, due to automation, all the products and all the stuff will be done almost automatically. So without so much human in the loop. And in this way, you actually you can create a lot of value without needing the human work. So somehow this value can be redistributed to the people. But it's a very utopian view. I think it will be very difficult and maybe dependent also on the geographical location. So yeah, I think it's very difficult. These are very difficult topics, and I'm not sure how they can be solved in the productive way.
It's very much a concerning conversation. I know a number of people are concerned about. They're concerned about how does this impact the employment marketability of people who have vocational skills and people who are not technologically advanced. How does this affect their jobs and so forth? So, do you have? Does Final Spark have an idea on what we're going to be able to do for some of the people that will be disenfranchised?
I think Final Spark cannot have a solution for everything. So we definitely, I think this is much more for philosophical topics, and maybe I don't know. I think there are different type of people who should think about this. So we are just engineers. We are building software and hardware. We are expert in that, but on how to run the society, maybe that's a bit difficult. So we don't have solution for everything, definitely.
For sure.
But I personally think that there is still a need for some people for jobs which are not necessarily technology based, because you have always this element of human interaction, and there are actually many jobs which maybe will not disappear, which are based on human interaction. So who knows? Maybe will not be so bad.
Maybe it won't be so bad. I think that's a good way to look at it. Tell us something. So Peter Thiel was recently on an interview on a fellow colleague's podcast, and he talked about the emerging AI market and how it's going to be impactful to society. And in relationship, he spoke about the Antichrist. And that's a very far out philosophical religious conversation for sure. But I'm just curious, since we're talking about using human DNA and powering and being a generative source for technology, do you see Antichrist philosophy or Peter Thiel's comments something that will be impactful as far as using human DNA as a portion of helping technology?
I have absolutely no idea. I have not heard this interview, and this is
Oh,
way
you
beyond.
got to check it out.
It's way beyond what I could say. I don't know, but I think that people usually, they like to anthropomorphize stuff. So we like to see human traits in stuff which are not human. So also when we use living cells, that doesn't really mean it has to be different than using digital AI. So I think AI in general has some issues and some challenges and some hopes, but I think it doesn't matter so much if we run this on living neurons or digital hardware. That's my personal opinion, at least. And I think that just the fact that we use some biological material, it's just sparking some imagination. But I'm not sure it's justified. But maybe that's beyond my expertise.
And that's absolutely a perfect explanation. But I would ask you, do you see any philosophical or religious implications as far as this technology?
Well, philosophical, definitely. We actually get a lot of questions from people from all over the world, which are about our work. And we recognize this need for answering philosophical questions. So this is why we put a lot of effort to reach out to philosophers, actually, to encourage them to work on this topic of biocomputing, because indeed it's interesting also from ethical also point of view. So we hope that soon philosophers will bring some answers, and that there will be some studies soon which can answer some of the philosophical topics related to biocomputing.
No, since you're at the forefront of this, Doctor, you must have a philosophical perspective. What's your philosophical perspective on how this is going to impact society?
So, well, we are engineers and scientists. So what we always try to do is to make the world a better place. And you usually have, as a scientist or engineer, you have a dream, to make stuff which are useful and make our life easier. So that's our general philosophy. But we are not too deep in the philosophical topics. So for more, in-depth analysis, we have to reach out to real professional philosophers, because they are trained to think about this in more systematic way. So I think it will be much more valuable to listen to real philosophers.
Now, does this have any spiritual implications?
I don't think so. I don't know. But it's outside my expertise. I cannot tell you.
I'll dig it. So in your expertise, when you're seeing how society is advancing so rapidly. Alvin Toffler wrote a book called Future Shock. Are you familiar?
No.
So he was saying that the technology is going to move so fast that human persons, pardon me, are going to have a hard time catching up. So now with the technology of biocomputers, is this going to be one of those things where we as a people have to catch up, or are we going to be falling behind? How does that work?
Well, I think general progress is very fast, also biocomputing, but not only. So I think it's more on technology and science as a whole. And I agree with you that the speed of development is increasing. So, for example, if you are a scientist today, you study some topic in biology, it's almost impossible to actually catch up with all the literature from the field. Already, there are so many papers published every year that it's impossible to catch up. So, with everything. So that's why, yes, I think it's happening. And indeed, the progress is faster and faster. And maybe we can expect that only acceleration, because actually with the development of large language models, we can see even further, speed up, because large language models, they even maybe will be able to run research for us. So it will be full automation and even faster. So yes, it's getting harder to be, in the past, for example, a few hundreds years ago, you could have a person like, I don't know, some people believe that Goethe was such a person, the German writer and scientist, that you can have all the knowledge of a current humanity in your head. But now it's not possible. So the farther we go, the more it's difficult even to have all the knowledge from a specific field.
So now, where is this going to take us, Doctor? Give us a 5-year plan. Tell us where biotechnology is going to take us. Give us a vision of that within the next 5 to 10 years.
So we are currently working on the next milestone, which is learning in vitro. So that means we would like to...
Please forgive me 1 second. Learning in vitro?
Yes, learning in vitro. So the same thing.
Explain that.
So learning is when you are learning also in your brain, that means that the connections between neurons are changing. So that's how we learn. The brain is plastic. And the same process we would like to get in vitro on the neurons in our lab. So we would like to be able to rewire the connection between neurons. So that means learning, so that you can change the connections between neurons, and we would like to be able to control this process. So that's the objective for the next 2-3 years. And after that, we would like to work on advanced algorithm so that we can match the performance of digital computers. And after the next stage, which will be around 3 to 4 years, will be the scaling. So we would like to make huge structures of neurons. So today we are working on a small little bulb of cells, which is around 10,000 neurons each. But in the future, we would like to make a much bigger structure of neurons, so that hopefully then they can process information more efficiently. And there is a lot of...
Hold on 1 second. I just want to back up. When you like to make a large factory, I wasn't sure, of neurons, please explain that part.
So this is not battery. This is actually processor. This is important. So processor, so that would be processor, huge, which can process information in the form of living neurons. So that's what we would like to build.
How does that work? Explain that process. Where would that be? What does that look like?
Well, we don't know yet, because it's still the future and we have to figure out how to build this. So this is an area of active research. But we know for sure that we would like to have the structure of living neurons. But how exactly it would look like, it's a lot of also experimental work. So we cannot say this before we build this and before we see experimentally that it really works.
Now, does this have any ethnicity issues or racial issues by any chance as far as neurons go in the biodiversity? Does this have any concerns where people who have racial issues or ethnicity issues, should they be concerned that this some of this could be that now we're only going to use white cells for the neurons for the computers, or black cells or Spanish cells? Is any of that part of this technology?
I think it really doesn't matter because neuron is neuron. So I don't think there would be any difference. So it totally doesn't matter practically. But that's what I think, of course. We would have to test. But I think it really doesn't matter which kind of neurons, because we all have the same neurons.
And now, how long has some of the studies been going into that? Now that I've just thought about that, have there been a portion of the studies on this going into some of the racial aspects?
No, I think it really would be, you would need to have huge imagination to think about this. I never heard about this.
And then where is the profit margin? How do, or so the companies that are going to be using some of the biological aspects of this technology, there's a profit margin. There is something that comes into profit. Is Final Spark a part of that profit margin?
Yes, definitely. Well, in the future, of course, today we cannot really make money, significant money with the technology because we are prototyping. But in the future, we expect this will be very profitable technology. We actually expect billions of profit, not only revenue, because like today you make money with silicon hardware. In the same way, you could make money with the neurons hardware. So actually, we believe it will be very profitable.
So now, how is it going to become profitable? So me, Seth Guru, I would come in to see Dr. Kurtys. How do you make your money? So I come into you and say, I want to donate some of my cells. How does this work where you guys would be able to make money, or companies would be able to make money from this?
So actually, there are many ways. So we have not decided yet. But you could look, for example, on NVIDIA, how it's making money. They produce chips, digital chips, and they sell them. So this is how they make money. And
what was the name again? What was the name
NVIDIA,
again? NVIDIA?
yes. So they produce chips and they sell them and they make money. So we could do the same in the future, making bioprocessors. Or also you can look at the companies which have cloud computing, which run cloud computing. They run servers. You connect to them and you pay for the cloud service. So the same way we could also make money if we build our own bio server and we run this. So there are many ways actually to monetize this. And this is not the biggest problem, because the biggest challenge of this project is actually how to program neurons, how to make efficient processors. So this is the biggest worry. And if it works, then making money will not be a problem, what we believe.
So starting with companies, certain companies would contract with Final Spark and say, we want to donate some of our cells. How would that process work?
No, that is not possible because we buy commercially stem cells and we don't care about the donation. Although actually it's funny because many people come to us and they would like to give us the skin cells. So maybe one day we open such a possibility, but that would be fully commercial. So so actually someone would have to pay us so that we take the cells from this person. And if you want to see your cells in action in the lab, you would have to pay this as a service. And actually that would be interesting idea. Because we see a lot of interest in actually people willing to give us the cells.
Now, how would I describe this if I want to promote your organization? What would be my tagline? Give me a tagline for Final Spark and human cell research.
No, actually, human cells, many people do on human cells research. I would rather say we build computers from living neurons. That's very specific, what we do. And we have a lot of actually platforms, let's say a lot of ways to promote. We have website, finalspark.com. We have also Discord channel. There are a lot of discussions. There's also technical. Of course, we have LinkedIn profile and X profile. So if people are interested, we highly encourage also to share the posts from us and to try to promote this line of innovation.
And I would ask, there's a spiritual aspect to this, Doctor. I'm sure you'd agree. What is the spiritual connectivity to this whole dynamic? Because this is quite an advancement as far as how we see ourselves as people. So, what are the spiritual implications to using human neurons for generative computers? What are the spiritual implications? What do you feel about that?
I think what you described can be also considered as philosophical considerations. And we indeed, when we talked with philosophers, they told us indeed that the way how we see ourselves is changing. And there is, some people question where is the border between human body and technology. Some people feel worried that this border is not sure, but actually since many, many years, technology is changing us. And even, for the fact that we have smartphone is kind of like extension of us already. So, this interaction between human and technology is actually happening since the beginning of humanity. And technology always is changing us tremendously, because our life today looks totally different than 100 years ago or 500 years ago due to technology and science development. So I think I feel very comfortable about this, but I think philosophers, they can also help us maybe to consider this, how this is changing.
It's quite a dramatic change from how we view things, Doctor. And I must admit, I was so looking forward to this interview because I find that there's a great deal of conversation that must be had as far as how does this impact how we look at we as an evolving species. Now we're evolving into using our DNA for computers and the technological advancement of our computers. And I think this is a strong conversation to be had. I was really curious about what your thoughts are on that.
Thank you.
Absolutely. So now tell me, so Final Spark, the organization, what was its origin? It started out as what?
We already discussed this.
Oh, that was not what I meant. Please forgive me. Final Spark, the organization. So in Final Spark's designation, that's what I meant to say. They're going forward. They're working forward with other organizations to be able to create. Actually, I guess the question would be: Final Spark, the organization, is working with governments or private organizations.
Actually, we work a lot with universities from all over the world. They connect to us remotely, and they try to do some experiments in our lab remotely. So yes, we have a lot of collaboration. That also means that our work is really scalable, that we can get involved more and more people in trying to solve this very difficult problem. So I would say mainly research organization collaborate with us. And of course, we have a lot of interest from industry and for individuals who want to also get some access to biocomputing.
And please forgive me for, I didn't mean to rephrase the question that way. So thank you for allowing me that opportunity to reframe that. And so now I'm curious, recently I've been seeing a great deal about synthetic AI. Is synthetic AI involved with some of the biodynamics of DNA?
I'm not sure what you mean by synthetic AI.
I just saw it's called Famous AI, and I've been seeing it's two companies that I've been seeing that are prompting synthetic AI, and they're supposed to be a more advanced form of AI technology. And so I was curious if you had any understanding of what that meant, or if it was involved in some of the biodynamics of our final sparks and some of the bio DNA.
No, actually, I don't think so. So I just look at the internet that synthetic AI can be understood either as synthetic data, which is not really relevant for what we do, or synthetic intelligence. Synthetic, no, I don't think so.
I know it's an emerging technology, so I was very curious if there was any correlation to Final Spark or anything of the sort with the bio portion of it. And if it's not, it's just one of the new things I saw. It was Famous AI, and they were talking about how it's faster than our recent understanding of AI. So I was curious if it had anything to do with Final Spark and so forth. And now, so now that we're going this, is this the direction that Bill Gates and a number of technological organizations are going to be going, is to use more in line with Final Spark and the organizations that are using human bio neurons and so forth to profit that because it does save energy? Or is it going to be like the electric cars where we have to find hybrids where some of it is going to be human DNA and typical?
I think it's a good question. No, we definitely think that there will be more hybrid system because the neurons will always be connected to the digital hardware. I believe so.
Okay. And now, where are you hoping to be able to spread this? Is it just to be able to be in the European markets, or is it also to be able to spread globally in the United States markets?
Definitely globally.
Explain, if you don't mind, elaborate.
Well, we just don't see the reason why we should restrict ourselves to the local market.
And I'll dig it, and not just to the local market. And so, how does this work for the average customer?
Well, as I mentioned, the AI will be cheaper. So that's what we want to achieve. So the only difference will be that it will be cheaper.
So me as the average customer, I want to be able to utilize this. What would happen? How does it make it cheaper for me?
Well, that you will in the future. Now it's difficult to imagine because today using LLMs, for example, is not yet that expensive. But in the future, you might need to pay for subscription much more because it will cost more. Because the better AI models are, the more energy they use, so you can expect that the price will increase. So that means that the models which are run on living neurons will be cheaper, maybe 10 times cheaper. So that will be reflected, for example, in the price of subscription or price of the cloud computing. Depends on which model we will choose.
Now, how does that mean? So now I guess I'm really going to dumb this down. So I repeated myself twice with two questions. I don't want to do that again, but I want to be able to help you understand for our audience. So in order for me to pay for this service, does this mean that once, I want to see how to phrase this. So each month I would come in and donate DNA, or or I would pay a subscription. How does this work? So currently we have Netflix and Apple TV and those kind of things as far as subscription services. How would this work as far as human DNA being a part of a regular subscription service? And I don't know if that's actually the right way to put that, doctor. Please forgive me, but how would this work in a regular marketplace as far as participation from we as a citizen?
I think you make association too far. It's just the computing power will be cheaper, and it's difficult to say what will be run on this in the future. It's just too early, I think. So, but imagine you connect to cloud computer.
That's fair enough.
And you pay a monthly subscription for cloud computer, so biocomputer would be cheaper.
Okay, and that does explain it. And some of this I'm coming from kindergarten, so please forgive me, doctor. And I appreciate your patience with me trying to understand this. Does that make sense?
Yes, of course.
For sure. Now, also, so 10 years from now, where are we seeing Final Spark?
You asked already for this.
I don't mean to repeat those questions. I'm so sorry, doctor. I guess I'm more so seeing as far as when we're looking at some of the robots and those kind of things. I guess I was asking for more elaboration in that sense.
We didn't talk about robots. We talk about bioserver, a centrally available bioserver.
So none of this has anything to do with any of the robots or anything of the sort?
Well, at least we don't plan this. And I don't know, maybe robotic companies will decide to use our technology, but that's beyond our scope.
Okay. Okay, so I definitely understand that. What else can you add? Because I don't want to repeat some of the questions that I feel like I didn't understand. So please forgive me, doctor.
I think I have nothing more to add. I think we used the topic really extensively from back and forward.
I really I hate that any things that are repeated. I just really feel like, oh, you know what? I think the simplest way I could put it in my apologetic form, we're in such an unknown territory. The repetitive nature of some of my questions is because I feel that we don't have enough information that lets us know where we're going. And so I feel like a lot of us are trying to really understand how does this work. So please forgive me with trying to simplify things in a repetitive nature.
No, it's perfectly fine.
I thank you very much. Dr. Kurtys, anything else you want to add?
No, I invite everyone to join finalspark.com to check our website and reach out to us if anyone has any questions.
Doctor, thank you so much. Please forgive me for my novelty, inexperience in repeating some of the questions I thought that I had already asked, because I really wanted to be able to make sure we broke down the information. So I hope that I didn't perturb you too much with some of my trying to understand it even more.
No problem. Thank you so much for your interest in our project.
We are extremely interested in the project, and I feel that, as I mentioned earlier, Alvin Toffler, there's certainly a unknown territory that we're in right now, and I think we're really trying to advance ourselves in understanding how things are going to work. And so it's a lot of information to process. So I thank you so much for taking out the time to speaking with us today.
Thank you very much.
Absolutely, Dr. Kurtys. Please do know, give us your website links and so forth where people can find out more.
Mm-hmm.
Please give us your links and so forth. Say your links one more time.
Finalspark.com.
Finalspark.com. Ladies and gentlemen, this is the revolution that we always wanted. And we are in a new field. And as you can see from some of my repetitive questions, I myself am a novice in understanding this field. And we are extremely appreciative of Dr. Kurtys to come and be so patient with me today to be able to explain this. Finalspark.com. We are looking forward to all the new things that go forward. We are moving in a new technological age, MakerSpar audience, and this is where we're at. Please do know we should do our due diligence as far as our research. Thank you so much for joining us today. We're looking forward to seeing you the next time. Revolution, revolution, we want you too, Doctor. Have a good day.
Thank you.
You got it. Bye-bye now.
Bye-bye.